Before I get into the different types of reactions, one of the things you have to note is that anytime you have a reactant in a reaction, it will yield, which is this little arrow, the product. So that's just a little order thing. Another thing that you should know is that there are these elements called the diatomic elements, and there are 7 of them, and anytime they are by themselves in a reaction, they have to have a subscript 2 following the letter. So basically, with the exception of hydrogen, they all form a 7 on the periodic table, which is convenient to remember because there are 7 of them. And so hydrogen would be H2, nitrogen N2, oxygen O2, fluorine F2, chlorine Cl2, bromine Br2, and iodine I2. There are 6 different types of reactions. The first and the most basic one is called synthesis. So basically, in this reaction, there are 2 parts, A and B, that produce a whole, AB. The next reaction is called decomposition. In this reaction, one reactant, AB, is broken up into 2 smaller parts, A plus B. So if you think about something decomposing, it's breaking up into smaller pieces, which is a nice trick to help you remember what decompositions look like. The next reaction is called single replacement. In this reaction, there is one lone element, A, that reacts with a compound, BC, and that would make B plus AC. So basically, so in this kind of reaction, each element with a positive charge will switch, or each element with a negative charge will switch, depending on the situation. So let's say A has a positive charge and B has a positive charge, then they can switch. But if A has a negative charge, B has a positive charge, and C has a negative charge, then A and C would switch. So it really just depends on the situation. This next reaction is called double replacement, and it's probably the most difficult of all the reactions, but it is not that bad. So here there are 2 compounds, AB plus CD, that are added up to yield CB plus AD, or that they're switched to yield CB plus AD. So basically, this double replacement has the same rule as single replacement with the positives and negatives, and yeah. The next type of reaction is called acid-base. This is a specific type of double replacement where one of the switching ions is an H or an acid. And so in this example, so basically since it's double replacement, there's 2 compounds that yield another 2 compounds. So just like the last double replacement problem, the A and the C switch because they will both have either a positive or a negative charge, so that rule also applies to acid-base. The last reaction type is called combustion. This one is a little confusing, but so basically in a combustion reaction, it has to have a fuel source, which is CH and oxygen, which those 2 burn together, and it makes water and carbon dioxide. So this reaction will always have these 4 factors, but it also can have more factors in more complicated problems. Something else about combustion that I'm going to get a little more in depth in the next video about balancing reactions is that just because in this reaction H has a subscript of 4 and C has a subscript of 1 doesn't mean that it can't have any other subscripts. Like O2, O obviously always has to have 2 as a subscript, but so basically what I just added, this reaction is unbalanced, but just to show you that H can have 10 and C can have 4, so it doesn't just have to be how this example is.